Hey guys, thanks for jumping back into another video of the Kubernetes series. Now I have a disclaimer to give you. I realized the first episode about architecture with the demo and all the explanations was quite long, and I'm not aiming for that. I don't want to bore you guys or give you a lot of information at once and just fatigue your brain. So I'm going to change the format to shorter videos, like nuggets of information, which I'm going to give you in a more condensed manner. So today's topic will be on how do we deploy an object into Kubernetes, and that's it. Yeah, so we're going to keep the information focused, and without further ado, let's jump into the theory. So how do we create an object in Kubernetes? Well, as I mentioned in the previous video, which will be linked at the end of this one, the API server, which is the component we communicate with when we try to talk to a Kubernetes cluster, is a simple REST API. Well, it's not simple, but it's a REST API. And that means you have specific ways of interacting with it, basically through approved verbs like get, patch, post, put, delete. So when you're trying to create a new object in Kubernetes, you're actually either doing a post or a put. Yeah. And basically, you need to send a request towards the API. And in the body of your request, you need to tell it what you want it to create for you. I know this is not very easy to understand, but basically, as you can see here on the screen, you just need to send it a YAML manifest or a JSON manifest. Yeah. So this is the manifest of the object that you want the API server to create for you. Diving deep into detail, if we were to create, let's say, a pod, we would employ a YAML manifest of the pod and a tool like kubectl to send that manifest to the API server. So in our example, we would have the manifest of the pod here, and then we would make a post call into the API v1 namespaces, the name of your namespace, pods, endpoint. Yeah, so this is where you need to send a request for it to be valid and taken into consideration by the API server. Now, once the API server receives that, it says, oh, okay, good, new information, I need to deal with this. So it will store this information into the store of value of the cluster, which is etcd. Yeah, it will update the desired state. I need a new pod, okay? And then the scheduler will notice that the state of the cluster, the desired state of the cluster has changed, and it will try to make the current state equal to the desired state. So what this means is it will try to find a node which has enough space on it to host the workload, and it will communicate with that node kubelet, telling it, hey, you have new work incoming, please create this pod for me. And then the kubelet on the node will actually go to the container runtime interface and container network interface and will instantiate the pod onto the address space of that node. Yeah, this is basically what's happening behind the scenes. Obviously, the steps are slightly different based on the resource you're trying to deploy. So when you're trying to deploy a pod, it will differ from a config map or from a namespace slightly, but the big idea still stands. Yeah, you're talking to the API server updates the desired state in etcd, and then the cluster's control plane mechanisms try to make desired state equal to current state. And now on to the final part of this video, the demo. As I told you guys, I'm gonna keep it as short as possible. So we're going to deploy one of the simplest objects into a Kubernetes cluster, and it's actually the namespace. A namespace in Kubernetes is like a logical container. Okay, so if you want to logically separate applications that should be running together, let's say you have a front end and a back end, you might want to put them both in the same namespace, because when you delete the namespace, the resources inside of the namespace get deleted as well. Okay, so I'm going to create this namespace. This is how the YAML manifest looks like. Yeah, any Kubernetes object needs to have these three properties. So API version, and we're now at version 1. Kind, this is the kind of resource you're trying to create. So you need to tell the API server what resource it needs to instantiate for you. And in our case, is going to be a namespace. And then metadata, we want a namespace whose name is my minus namespace. So let's jump straight into that. Here we have the YAML manifest here, and I'm going to be using the Rancher desktop Kubernetes, which is basically a mini cube, mini cluster on my machine that comes with Rancher desktop. If you've installed Rancher desktop from one of the previous videos, you'll have it. If not, I'm gonna leave the link in the description below. So kubectl get namespaces, and you'll notice that we already have some. Actually, the kube system hosts Kubernetes applications. So if you do kubectl get pods in kube system, you'll see there are some pods created by Kubernetes to run itself. So it's using its own constructs to run itself, kubeception, yeah. And all the other namespaces are defaults, yeah. So when you create a cluster, you get all of these. So now I'm going to create one of my own, and it's fairly simple. All I need to do is kubectl apply -f for file, and I'm going to say that I want /kubernetes/ okay, and namespace.yaml. And basically it says that my new namespace is created, and if we do kubectl get namespaces, we will see we have a new namespace called my namespace. And if we want to delete it now, we need to send a different request to the API server. We either do kubectl delete -f and same kubernetes 02 namespace.yaml, or you can reference the resource by name. So now that we know we've created it with this name, we can say kubectl delete namespace and give the name of the namespace that we want to delete. And it's done. Now, as you can see, my terminal is still waiting for Kubernetes to tell me that, yeah, it's fine, I deleted the resource. And now when we do get namespaces, you'll see the one I just created got deleted. So I hope this clears mainly how you can interact with a Kubernetes cluster and how you can ask it to create resources for you, and how to manage those resources via certain YAML files or kubectl commands in our case. Thanks a lot for watching, and I'll see you on the next one. Cheers!